Now in this class, I'll discuss with you the topic Kirchhoff's laws. Okay, so just listen. Kirchhoff's laws.
Gimana? Gimana banget tuh? Nina, ada masuk.
Kirchhoff's laws.
Dio.
As you know well, so this is the problem related to the Kirchhoff's first law or junction law. We need to calculate the I value in the circuit diagram. I is equal to question mark. Very simple this is. Apply the junction law. Junction law means, observe carefully. From here 3 ampere is coming. From here 2 ampere is coming. This 3 ampere and 2 ampere both are meeting at this junction and gives the 5 ampere. 3 plus 2, 5 ampere. This 5 ampere is moving in this direction. At this junction, again separation takes place. Separation takes place. In this 5 ampere, 2 ampere is moving in this direction. The remaining is how much? 3 ampere. In this 5 ampere, 2 ampere is moving in this direction. The remaining is 3 ampere. Okay, now at this junction, 3 ampere is coming from here, 1 ampere is coming from here. This 3 ampere and 1 ampere both are combined, gives the current as 3 plus 1, that is 4 ampere. And thereby, here I is equal to how much, ma? 4 ampere. That's it. This is another model. This problem is combination of the, this is also related to the Kirchhoff's first law or junction law. Now observe carefully. Here the question is in the circuit shown in the figure, the current I is, here we need to calculate the current I value. I is equal to question mark. Simple, no complication. Listen. Here when the current is moving from one end, that is at higher potential, and here I am taking the junction is P. At first I am taking this branch AP branch I am taking. Current is moving in this direction. A is at high potential, P is at low potential. So now this I is moving up to P. If P దగ్గర ఏమవుతుంది అని అంటే at P the current is dividing into two paths. ఇలా వెళ్ళిపోయింది చూడమ్మా, ఇలా వెళ్ళిపోయింది. So some current is nothing but here I1 I am taking, and this current is nothing but I2. I1 is the current passing through the 2 ohm resistor. I2 is the current passing through the 1 ohm resistor. 1 ohm resistor. Okay, now listen ma. See, so from that I am taking up, by taking the Kirchhoff's first law, I is equal to what's the value? I1 plus I2. Sum of currents entering into the junction is equal to sum of currents leaving from the junction. Apply the Kirchhoff's first law. From that, I is equal to I1 plus I2. And now here I am taking that I. According to Ohm's law, V is equal to IR. Then I is equal to what's the one? V by R. V by R. So potential by resistance. Potential. Here I need to take potential difference. At A potential, at A the potential is VA minus at P the potential is VP by resistance is what's the value? 3 ohm by 3. In this branch the resistance is 3. The resistance is 3. Now is equal to I1. So now this is the starting point. P is the starting point. B is the ending point in this way. So current is moving from P to B. P to B. So P is at high potential, B is at low potential. Why? Because the current always flows from high potential to low potential. So Vp minus Vb by resistance. Resistance is 2 ohm plus I2 related to this branch. Again the current is moving from P to C. So P is at high potential, C is at low potential. So Vp minus Vc by 9 by resistance. That resistance is 1 ohm. 1. Now observe VA. What is the potential at A? 24 volt given in the problem. Minus VP by 3 is equal to VP minus VB. Potential at B is 10 volt by 2 plus VP minus VC. Potential at C is 9 volt given in the problem. 9 volt. 9 volt. C. At potential at C is 9 volt. Getting? Now here and take the LCM. 24 minus VP by 3 is equal to, and take the LCM. 2 is the LCM here. VP minus 10 plus 2 is the LCM. So 2 VP minus 18 by 2. 2 VP plus VP, 3 VP, 3 VP minus 10 minus 18 minus 28. So here I am taking the 24 minus VP by 3 is equal to VP plus 2 VP, 3 VP minus 10 minus 18 minus 28 by 2. By 2. Now, here take the cross multiplication. 24 2s are 48 minus 2 VP. 3 3s are 9 VP. And 3 into 28. 3 8s are 24. 3 2s are 68. 84. Now, you see here, minus 84, take this side, plus 84. 84 plus 48. And that is 132. Minus 2, send that side, plus 2. 9 plus 2, 11 VP. Then VP is equal to 132 by 11. 11 1s are 11 2s are 12 volt. The potential at P is at the junction value is 12 volt. This is one question. What is the potential at P? If they ask immediately, this is the procedure need to follow. VP is equal to 12 volt. But here we need to calculate the I value. I related to what? AP branch. So AP branch related to what? I is equal to, this is the value formula, VA minus VP by 3. Now I is equal to VA minus VP by 3. What is the VA value? VA is 24. What is the VP? Just now we calculated the 12 volt. 24 minus 12 by 3. 24 minus 12, 12. 12 by 3 is nothing but 4. The answer is 4 ampere. This is the way to do the procedure. I is equal to 4 ampere. Got it, ma? So this is the given problem. In this given problem, we need to calculate I3 value. This circuit is simplifying like this. Both the cells are in parallel combination. If this EAF line is connected to the F point, AF is entire same line. So if you connect it to the F or if you connect it to the A, both are same. So I connected from here, this part, 9 ohm. And same, if you connect it to C or if you connect it to B on this line, everywhere if you connect, anywhere if you connect, that remains same. So I consider like this. And from this cell I1 is coming, from this cell I2 is coming. From I1 and I2 both are moving towards this side, that is I3, that is moving like this. The current passing through the 9 ohm resistor is I3, that we need to calculate like this. And this circuit is very similar to the part which was given by me earlier with a formula. What's that formula? I is equal to E1 by R1 plus E2 by R2 by 1 plus R into 1 by R1 plus 1 by R2. Now I is equal to E1. What's the E1 value? 8 volt. R1 1 ohm. E2 12 volt. R2 1.5 ohm by 1 plus capital R resistance, external resistance 9 ohm, and 1 by R1. 1 by R1 is nothing but 1. 1 by 1 means 1 only, plus 1 by R2 means 1.5. 1 by 1.5. If you solve this, then you will get that I value, that itself is nothing but here I3. I3. In this problem, that value is I3. I3 is equal to, what's the value, ma? 1 ampere you will get if you solve that. Okay, so this is the answer. Like that, we need to solve this problem.